All right, these videos will cover 803 using calculus with data in a table. So we're just going to do some examples of some things you might see in the assignments and exams. Okay, first example. The function f of x is continuous on the interval 311 with some of its values given in the table below. Find the average rate of change of f over the interval 311. Okay, so whenever you see the word average rate of change, it's the slope formula. It's the change in x over the change in y, slope formula that you learned in Algebra 1. It looks like this in advanced math. And because we're trying to find the average rate of change from 3 to 11, these are the points you're using. 1x equals 3 and 1x equals 11. So you find the y-coordinate when x equals 11, which is given, and when x equals 3, given, and 11 minus 3. So this is a pretty straightforward problem with a whole bunch of words. Okay, so now the next one, same table, same function, same interval. Use the data in the table to approximate the derivative when x equals 9. Now, this is the function. We don't have the equation, we just have points, so we can't make any assumptions, like we can't actually use any derivative formulas, but the derivative is essentially the slope formula. This is the change in x over the change in y. I'm sorry, I said that backwards, the change in y over the change in x. And the x coordinates, the distance between them is 0. They're like literally on top of each other. So instead of it being 2 points that are separated, it's really 2 points that are so close together that the distance between them on the x-axis is nothing. That's really what this is saying. Okay, so it's the slope formula. We don't have anything to actually use except for an estimate, and the closest estimate we can make is between 10 and 8 here. So this is just like the last problem where we're just going to have to use a slope formula and find our closest 2 points to get to the 9. The closest to the 9 that we can get, the better. So that would just be 16 minus 10 over 2. Okay, next one. All right, we got this table here with x values and 2 different functions and the derivative values. So f of x and g of x are differentiable functions for all real numbers. H of x equals this crazy looking thing, composite function. Composite means we have stuff plugged into itself or another function. And now we have table below gives selected values for f, f prime, g, and g prime. Find the value of the derivative of h when x equals 1. So we should start by actually finding the derivative of h, right? If h of x equals this function, it's a composite function. If you find the derivative of a composite function, then you need to use the chain rule. So there are layers here. There are 3 layers. The outer layer is f, the inner layer is g, the innermost layer is 4x. So when you take the derivative of any kind of function that has layers, you need to just treat it like an onion, where you can only see the outer layer first. Like everything else inside stays the same. So when we first take the derivative of the outer layer, that would be the derivative of f. The inside stuff doesn't change. And then we move on to the next layer, which is g. The derivative of g is just g prime. The inside stuff doesn't change. And then we move on to the next layer, which is 4x. Derivative of 4x is 4. So you have to take the derivative of each layer separately, but as you take the derivative of the outer layer, the inside stuff doesn't change. It stays along for the ride until you get to it. So this is the derivative of h of x. We can now plug in a 1 for x. So 4 times 1 is 4, 4 times 1 is 4, and then this 4 stays. And now you can start using the table to find your data. G of 4 is right here. G prime of 4 is right here. So that's why there's a 6 and a 3 right there. And now we need to just find f prime of 6, which is 2. That's where this came from. So final answer is 24.